I got taught something today by my teacher, Kiley. I wanted to talk to you today about this thing called carbon dating. So basically, what Kiley explained to me is what happens with what carbon dating is it takes the measurement of carbon molecules, carbon 14 and carbon 12. But real quick before we get into that part of it, I want to explain what exactly the difference is between carbon 12 and carbon 14. So if you zoom in here on this bowl, come on over here and check it out. All right, so in this bowl here, I got some golden grams, and that represents carbon 12. Okay. Then the other thing, I don't have a fancy diagram for the other ones, but these Cocoa Puffs are nitrogen. So what happens is these things are all floating around up in the upper atmosphere, and you can zoom back out. But what happens is these things are all floating up in the upper atmosphere, and so then the sun's rays are coming down, and they're hitting these nitrogens. Okay, they're hitting them, and what's happening is some of the nitrogen loses its protons, loses a proton that just goes away, and the other one becomes a neutron. And so since it lost that part of its profile, it's no longer nitrogen at that time, it becomes carbon 14 right there. So if we look and try to use this as a demonstration, if you take some of these Cocoa Puffs, and they just go away, I'll shoot them. Okay, those go away. And then you get these other carbons that come in that look like carbon 12, but they're carbon 14. And I'll represent those with Cinnamon Toast Crunch. It looks a little bit similar to, the golden grams, but it's a little bit different, okay? So we'll put some of those Cinnamon Toast Crunch in there. Let's see, 2, 4, 6, all right. No, let's do 2 more, all right? So now these things are all floating around up there, and they're coming down into the atmosphere, consumed by plants, and eventually, like an animal comes up and eats it. Then like let's say a dog comes up and eats that animal. So you got that carbon 14 and carbon 12 getting transferred to every single living organism on Earth. Well, what happens is, so if you go and you take let's just say we find this animal that's old. We found it fossilized in the Earth. So we're going to take out. We just want to measure the carbon that's in this animal. So if you want to zoom back in to over here with just the carbon molecules, what happens over time, the carbon 14 and the carbon 12, they're not the same molecule like we talked about. So carbon 14 is pretty unstable. So eventually it wants to change back over into nitrogen. So what happens is the Cinnamon Toast Crunch here, representing your carbon 14, if there's 8 Cinnamon Toast Crunches there representing carbon 14, and you got all these carbon 12s. Well, let's say over the span of, I'm just going to throw a number out there, 5,730 years, we'll just say that, and we'll call that the half-life of carbon 14. Well, at that time, half of these carbon 14s go away, and what you're left with is back to these nitrogens, all still in that animal, all still in the fossils. But what you can do with that, the carbon 12 stayed, but the carbon 14 changed. You can measure that, and you can tell how old a fossil is or an animal is to get to determine roughly how old this thing is. So that's what I learned from Kiley. I thought it was really enjoyable. Thanks for teaching me this, Kiley. I now feel more complete in life.